Good afternoon, ladies and gentlemen. It's about time to start the first session of the afternoon, which, as you can see from the agenda, is on security. We've got 3 talks this afternoon. The first one by John Lameth is on biometric standardisation, and then we've got 2 talks to do with spam filtering. So I'll introduce John Lameth to begin with. John Lameth is a professor from the University of Salford. He's spent the last 25 years on standardisation, first of all on ISO standardisation, the 7-layer model, for those of you who remember that, and more lately he's been working on biometric standardisation. So I'll hand over to John now for his talk. Thank you.
General, Deputy Prime Minister, ladies and gentlemen, let me say how honoured I feel to be asked to give this presentation to the Homeland Security Conference here in Jerusalem. Oh, sorry, restart. I always get mixed up about which capital, whatever we're in. You go to a standards meeting, you're sitting in a room, I can visit the room a long time afterwards, but I can never remember where it was. I think this is supposed to be the one we want. If you get bored listening to me, you've got a couple of choices. You can go back to the presentation on the UK biometric scene and the UK passports trial. You might find that more interesting. Well, if you're in the UK, you might. The other thing you can do is you can go to the paper that supplements the presentation, which is a much fuller tutorial on the biometric standardization and where it's all heading and things like that. And so if you're remotely interested in that area, the amount I can say in half an hour is pretty minimal. Let's move on and see where we can get to. I suppose you've all heard of biometrics. If not, go away and attend a tutorial or go to another parallel session. Yes, you know roughly what biometrics is all about, but how much do you know? Not wanting to be rude. I guess you all know about fingerprint minutiae, iris patterns, hand and finger geometry, of course. You know the digital representation of these for biometric matching is called a BDB, Biometrics Data Block. Now, simply a data structure which holds information about the measurements you've made on the distance between the eyes and the nose, on the features on a fingerprint, i.e. where ridges bifurcate or merge, and the distance between those, number of ridges between those, and all that sort of stuff. Simple, straightforward data structure definition. And BDB formats are standardized. There's also provision in the BDB work for people to use non-standardized BDB formats, because this is a very rapidly changing area. Just about everybody in every country have got some new biometrics that they think are the world's greatest gift to mankind. I was given a demonstration of quite an interesting new one in Israel, which I hadn't come across before. And it was just literally 2 contacts. It turns out that there's a potential difference between your 2 fingers. A small one, or between your 2 hands, a small one, and you can put those under contact. It passively senses the potential difference, and lo and behold, it's a pattern which repeats every heartbeat. And that's because the potential difference is caused by the surge of the blood around your body. And it's a characteristic of an individual. And it gives a very reliable rate and very fast checking. The other interesting thing is that the correlation between a pattern from one individual and a pattern from another individual in the same family, there's about a 50% correlation there, as opposed to virtually 100% between the patterns from the same individual at different times. So if you want bin Laden, they said, all you do is you go to all his relatives in the States, that's living in the States, and you record the patterns from his heart, and then if he passes through, he'll show up as a half correlation with those patterns. Nice idea. DNA is about the only other biometric that has that sort of property. Okay, so we know about standardization. Anyone in networking knows the importance of that. It's all about multi-vendor interworking. And those of you who were in networking a long time ago will know all about layering. We still even talk about it. Standardization of biometrics is very similar in a lot of ways to the standardization of OSI. There are many layers. There's about 6 different working groups. Just about every country in the world is represented. The US typically send a delegation of about 50 people. The UK feels about 24, 25. Japan, Korea is about the same. Most European nations are anything from 5 to 10, sometimes 1 or 2. Very much the scene we had with OSI. The base level for matching is the BDB format. And a lot of people think that's actually all that biometric standardization is about. There are approximately 29, 30 current standards being produced in biometric standardization, of which the BDB format standards are approximately 9. So there's more of something else. What's the something else? I'll tell you that in a minute. In layer 2, we talk about CBEF data elements. Like OSI, it's all riddled with jargon. So you've got to get used to BDB. You've got to get used to people talking about BioAPI. You've got to get used to people talking about CBEF, Common Biometric Exchange Format, File Format Framework. Bit more about what that is later. That's essentially a definition of metadata, things like, well, we've got a slide on it, so I'll come on to it, and also including another piece of jargon, the BER formats, and we've got another slide on that in a minute. Then we move on to standards for system integration. And that's essentially the BioAPI standard, which is layer 3. And then, dear to your heart, we actually have a little bit of networking in there. So the Biometric Interworking Protocol, the BIP, is a network application to allow an application on one system to access sensors on different systems and databases on different systems and do the comparisons and all that sort of stuff. And then there's some societal and privacy technical reports, in fact, that are being worked on and are being produced. So I've mentioned the BDB, the Biometric Data Block Layer, formats for digital representation of measurements of various physical characteristics. Sometimes those formats are nothing more than a digital image. And for the 2 main biometrics, face and finger, we have essentially 2 different BDBs, 2 different formats. One is simply a digital image, a digital photograph. The second one is minutiae extraction by effectively recognizing the geometry of the face, recognizing the minutiae, the ridges and the valleys and their positioning on the finger. So we sometimes have just images. We often have feature extraction. This slide's a bit busy. These are the 9 standards for BDB formats that are currently being developed. If you want to know a bit more about what these are really about and what the data structures contain, the paper associated with the presentation has got a fair bit more detail, so I'm not going to go into it in too much detail now. Finger minutiae is a relatively small data structure that records the relative positions of the ridge bifurcations and the ridge mergings. The finger image data is literally just a digital image of the fingerprint itself, and you would recognize it if you just brought it up on a screen and you could see it there. Finger pattern spectral data is dear to the hearts of some people. It's complex mathematics, essentially Fourier transforms and Gabor filters and God knows what, and some of you know more about that than I do probably. And that's what you record in the BDB. Similarly, we have face image data, we have iris image data, signature sign behavioral, signature sign process dynamic data. Signature sign, by the way, the sign bit means signatures as well as, initialing things as well as signatures. So that's why it says signature oblique sign. It's not just signatures. Why do we have 2 different signature sign behavioral data and signature sign process dynamic data? Well, I think most of you who've been involved in standards work know the basic rule. Everybody involved in standards has engraved on their heart, your job is to produce standards. If you can't agree, make it optional, or better still, another standard. And that's why we have two standards for signature sign. They couldn't agree on what was going to go in them, so they produced two separate ones. We can, of course, justify that. If one standard is good, many standards are surely better. And I can redress the balance slightly. In the beginning, there was chaos, and the greater gods descended, and each begat a new standard. And the people worshipped the standards and said, give us more, give us more. So the gods begat more standards and more, and lo, there was chaos once more. Critical activities at the BDB layer. Again, jargon terms. We talk about capturing your biometric, which means the initial measurement of the thing, and typically sticking it either on a smart card, which will go into your passport as a wafer-thin smart card, or will go onto a database. Processing it, feature extraction, looking for these minutiae, the face geometry patterns, and so on. And then storage in a burr, and we'll see later about that when we get onto the burr layer. And then 100 years later, you come back, and you get measured again, and if you're lucky, it matches the original, and you're allowed through the passport control, etc. If you're unlucky, you've grown up a little bit, and you've aged, and it doesn't match, so they throw you in jail. Or if you're in the States, maybe worse. So aging is an important worry. Biometrics is statistical. We talk about the false match rates and the false non-match rates, and you can adjust your threshold to effectively vary those as a trade-off between them. Interoperability and interoperability testing takes account of some of the additional standards that are being produced. Certification centres, reminiscent of networks again, folks, and matching algorithms, not in fact standardised, at least at this time. And so moving on to the second layer, the burr layer. You know about metadata. Metadata examples, the identification of the product that captured the BDB, the time it was captured, expiry dates, security people are well aware of those sorts of things. Security block format, signatures, and so on at the end of the burr. So we take a BDB, we add some metadata, stir well, cook it at a high temperature until it is burnt. And we have a burr ready for storage and archiving. You don't normally ever pass around anywhere raw BDBs. They usually have the metadata associated with them to form the complete burr. And they may or may not be encrypted, and the security block in the burr will say whether or not they're encrypted and will provide parameters for encryption, integrity, etc., etc. So we then get on to the biometric information record. That's the first time I've told you what the burr stands for. The CBEF defines the elements of the metadata. We have registration authorities for biometric organizations to get an unambiguous ASIN1 object identifier component. The IBIA, International Biometric, I've forgotten what IA stands for now. Issue is the registration authority, and we'll issue those. Anyone involved in biometrics can get themselves a biometric organization code. And they can then identify their own BDBs. Within that code, you get the general idea. Codes can be registered for security block formats and for so-called standardized patent formats. Patent format is just a synonym for burr. Why do we have two names? Way back in the history of biometrics, which is only about 5 years long. Actually, it's probably nearer 11. Patent formats are mainly binary encoding, so you've got your binary block in the middle, the BDB, those are always binary. But the metadata stuff wrapped around them, we can have binary formats, or you can, in fact, there's one XML format for holding the metadata for the burr. Burr is then the essential capsulating unit for storage and transfer. So enrollment is the act of capturing biometric data into a burr, which will contain a BDB, and then the archiving or storage of that burr on a database or on a smart card or both. Big Brother has measured you. If you can believe it, and you're in a benign regime, the burr will be put on a smart card, given to you, and the slate wiped clean. It won't be held in a database. Some firms that are concerned about unions not liking the idea of their employees' fingerprints being stuck on a database say, yep, we will wipe it clean, we will just give you the card, you will be the only one that will have your fingerprint. However, the UK passport scene, there's going to be a major database there as well, and forget about saying wipe the slate clean. But in any case, if you lose your card, you're better off if the database can replace it. So 100 years later, you present yourself for measurement again. You claim to match a bird in a database or one on a card you carry. And if you identify, then the match can be performed. But if you're being scanned by a CCTV camera, or the police have got your photograph and you won't tell them who you are, then they can do an identification match, searching the entire database to see which member of the UK population you are, and they've got you. Moving on to the bioAPI layer, this is an architecture for systems integration in a single computer system. So it is defining APIs. It's actually defining two APIs. We'll talk about those in a moment. One is called the bioAPI API, and the other one, the bioAPI SPI, System Provider Interface. And we talk about BSPs and BFPs, and essentially, bioAPI is all about passing burrs around the system between biometric devices and applications. I'll take the next slide fairly quickly. Fundamental to bioAPI is the concept of a bioAPI framework, which is essentially an extension of the operating system. It's the heart of any bioAPI system, and it glues everything together. Everything else can be from different vendors. And so we have a variety of applications running in that system, communicating with the bioAPI framework using the bioAPI API. The interface is actually defined in C as C calling sequences, but there's text in the standard that says that doesn't mean you've got to write in C, you've just got to be able to use C at the other side, if you see what I mean. And then we add the SPI interface at the bottom of the framework, which interacts with biometric service providers, which is, again, the jargon term for the pieces of software that encapsulate the actual biometric device, the thing that is going to capture your fingerprint or look at your face or whatever. So the BSPs produce burrs, they get passed up to the application might pass them down to a different BSP to do a matching, to another one to do a storage. There's about 4 categories of BSPs that are defined. And standardized interfaces there at the API and the SPI level. And beneath the BSPs, we have the biometric devices, and it broadly provides for the capture of a BDB, movement of the burrs, etc., etc. Move on a bit faster. Well, again, it's back to we want more standards. Man said the interface standards are good, give us more, give us more. So the biometric function provider was begat. The biometric function provider is essentially an attempt to provide a lower level interface than the BSP interface for people that are primarily hardware providers and are simply interested in providing the devices for the fingerprint readers, the hand geometry readers, the hand silhouette readers, etc. Okay? So it's a lower level interface which effectively avoids you having to worry about what metadata you want in your burrs. It's really just passing the BDBs up and down. Move on a bit faster. Okay, conformance testing. It's a multi-vendor architecture, bioAPI, and so there's going to be multi-vendor implementations, but will they really interwork? So there's a standard being progressed for how to do conformance testing of bioAPI systems. And there's conformance software being developed, and the US has already let out a research contract to a couple of different firms in the States to develop certification software for bioAPI with a view to, in due course, setting up certification centers in the US. There's no equivalent contract being let by the EU, to the best of my knowledge, in Europe. Moving up to layer 4, the biometric interworking protocol, the BIP layer. That's work still in progress. It provides interworking between different systems across a network containing capture devices or databases or biometric applications, and it's essentially based on communicating bioAPI frameworks. So it's essentially an extension of the bioAPI framework with, of course, fully defined messages, and there's pretty well a one-to-one correspondence between the parts, the functionality of those messages, and the parameters of the C function calls that go across in the API and the SPI. So you can see the way in which the BIP has been developed. Main application for biometrics is in authentication. You might or might not have noticed that one of the areas which is not currently being standardized in that list I gave at the beginning was BDBs for speaker recognition. Now, there is a very significant voice community that has not so far been represented in the biometric standardization at either the US or at the international level. But at the Jerusalem conference, there was an awful lot of interest coming in from them, and there were a lot of interesting devices that they were demonstrating. So if you make a mobile phone call, you can have a challenge response from the place you're calling. The challenge essentially tells you what you've got to say. You say it as your response. It recognizes the speaker from what you've just said. It's not subject to replay because the challenge can be different every time, and you have got an absolute identification that it is that person that is on the mobile phone, and you can charge them, obey their instructions, or whatever it is they're wanting you to do. That was an interesting one. Another interesting one is a web camera sitting on a PC, and it is permanently monitoring your face and measuring your face. And as long as it's you sitting there and using your PC, it won't lock the PC. Someone hits you over the head and tries to grab your PC, your PC blows up. That's the kind of rough idea. Broadly, it is horses for courses with biometric formats, with BDBs. And that's really why there are so many of them. Things where you can take a latent impression, fingerprints and DNA. In other words, if I'm around and I leave a fingerprint lying around, that can be picked up and it's there. And that can be later compared against a database. You don't have to have me in order to be able to identify the fact I was there. You have much the same property with DNAs. With many of the other biometrics, you don't have that latent capability. And people that are concerned about privacy and not being criminalized and all that don't like things that provide latency to be used for simple passport identification. Of course, people in law enforcement do, so you have a continuous tension. Privacy issues and acceptability issues are very much an issue in biometrics. There's more opposition, I think, in the United States to the inclusion of fingerprints in biometrics than there is in the UK. There's also opposition to having anything which smacks of being able to detect a medical condition. So measuring this pattern which comes out when your heart vibrates, the first question that was asked was, if in fact you've got a bad heart, could it detect the fact you've got a bad heart? And the answer seems to be probably not. There's also the serious problem of the one-eyed man or the multiple paraplegic. I mean, if you don't have any hands, how the heck do you give a fingerprint to get through into the States? So most passport applications of biometrics, and probably most applications in private firms, are going to be using multiple biometrics. So if you're incapable of enrolling on one for reasons of physical deformity and physical problems, you can enroll on another. In the UK passport trial, one of the biggest problems was people with learning disabilities, or people who'd got the shakes, and they just couldn't keep still long enough for photographs to be taken for the face measurement. So there's quite a lot of issues there. For each of the technologies, people will tell you very proudly what the FMR, FNMR graphs look like, and that's a fairly important factor. Still interworking problems between different vendors. Some of you might have heard of an International Labour Organization trial with seafarers, and they had 7 vendors of biometric equipment going through something like 200 or 300 seafarers to see whether if one did the capture of the fingerprint, the other one could read it. And it turned out that only 2 out of the 7, 2 out of the 49 possible pairs, could actually interwork. And those 2 turned out to be owned by the same group officer above them. Some of that was because they were using an old US standard and not the international standard. Some of it was just they'd misunderstood the standard. You know, the usual thing, again, go back to the beginnings of the OSI work. Big engine, little engine, integers. You remember that stuff? Some of them interpret the VDB formats as big engine and others as little engine. And, of course, they didn't tend to work. Problems of secure and trusted software for cross-network authentication. That's quite an interesting live area. The issue of e-authentication, authentication across a network, the speaker recognition people, of course, say we've cracked it because I just indicate how that would work. I indicated that across a mobile phone, but it'll work equally well across a PC. But there are quite a lot of interesting issues that are still being worked on very much in terms of the relationship between digital certificates and biometrics. And Japan is working quite strongly on effectively extensions of X.509 can incorporate and include the use of burrs within them. And I've actually managed to finish in time, maybe, for the odd one or two questions. Otherwise, you can gain 5 minutes. You can ask questions from the other speakers that you might be more interested in.
Thank you very much. No, that was very good. Do we have any questions, please?
Okay.
Well, hold on. People are still thinking. You present an awful lot of information to them. And does nobody want to ask John anything? Okay, well, let's give John
you can catch me over the coffee break if you want to.
Okay, our next speaker is Torgny Hallenmark. Torgny is a manager from Network Services Computing Centre at London University. He's going to talk about control of spam and what they've done at London University to control spam by the use of grey listing. So, over to you, Torgny. Thank you.
Oh, sorry. Oh dear.
Okay.
We're almost there.
Yeah, okay.
We've got it.
The wire is long. Thank you. Yeah, it's on. It is on.
Okay. Is it better like that? Can you hear me? Up there. Okay. And now for some completely different. Maybe we should have some biometrics coming through keeping track of spam messages as well. But I don't think we have it yet. Good afternoon. I'm going to give you a presentation on how we at Lund University have done some restructures to our central systems, checking mail, and especially when checking spam and viruses. And we did some changes 1 year ago, and one part that we hadn't intended to use from the very beginning was the grey listing technique, but that was actually one thing that helped us to reduce the volumes of spam quite substantially. So first, what is Lund University? It's a university not very far from here. It's in the very south of Sweden, and actually it's not more than 500 kilometers from Poznan. It's one of the biggest universities in Scandinavia. We have almost all education you can have at the university level. We have around 40,000 students. Well, depends on how you count them. We have 6,000 employees, and you have a web address if you would like to have some more information. We are running mail systems for employees, and we are running mail systems for students. Today we are running on parallel mail servers. We have one mail server for students, another mail server for employees, but we are mainly using the same software. We are using the Sun Java Enterprise system. There's a messaging server, there's a directory server, and there are some other servers as well. Sun has a habit of changing the names of these products once a year. So 1 year ago, the name was probably Sun 1, and even before that, the name was iPlanet. We're also using some other gateways, and in those gateways, we are normally using the SendMail program. We have some controlling system or some administrative systems keeping track of the users. One system called Lookat for the employees and another system for students. So it, in principle, looks like this. Lookat to the left, to the top, is the administrative system keeping track of all the employees, and Ladok is the same thing for students. The information on these persons are stored in two directory servers named LDAP here. So one for employees, one for students, primarily. But these two LDAP servers are interconnected so that each server should have the full information. They're set up in a multi-master configuration. And at the bottom you have two mail servers for employees and students. So that's primarily what it looks like. We have been using software for a long time, trying to keep track of spam and viruses. But 1 year ago, we were doing some thinking and some testing. And after that, we set up a bunch of new servers. We set up 3 Sun servers for this purpose. We have since then added a 4th server, or actually in the process of doing it. So we started to use this setup almost a year ago. And on spam detection, we are using mainly spam assassin software, and we are using the new gray listing software, or the gray listing technique. So, and on the virus side, we're using a commercial software, Sophos, and we are also using free software, Clam Antivirus. So those are the 2 of the tests we want to make. The third test that might show up to be quite essential is the address verification test. Since lots of messages arriving are actually sent to addresses that do not exist. So if you can sort them out, it's quite useful to do it very, very soon. Okay, so this is the structure we're using today. The mail gateway system at the top right, 3 systems. I said that we have a 4th system coming in. That system, or those systems, take care of the spam and virus control, as well as the address control mentioned, the address verification. And all this is done in an early stage so that we could stop messages as soon as possible without having them to arrive at our mail servers. What happens next is that the messages are delivered to the mail server and stored in a mailbox there. The user can connect to the mail server and pick up the message in some different ways. We also have some local mail servers in various departments for some reasons. So they normally are taking care of the mail service for their local domain or local subdomain. And To the local mail servers, mail can be delivered in two ways. One way, the left arrow, is the way of setting up a DNS MX entry pointing directly, for that subdomain, pointing directly to a local mail server. The other way is going through the central mail gateway and doing these checks for spam virus in the mail gateway before the message is delivered to the local mail server. Okay. This summarizes almost the same thing as said. We have a central mail server and taking care of somewhere around 75% of the employees today. The other persons are using the local mail servers. Before going into the spam side of this, one single slide on virus. We are using the Sophos antivirus software, commercial software, and we are using the CLAM antivirus software as well, in the hope that it's better to have two checks than one. If one should fail for a virus, perhaps the other works better. We are, when detecting a virus, flagging the message in the subject line with this text virus. And when we are passing the message on. However, if we detect an infected attachment, that attachment is removed and replaced by an information text so that the user should avoid to be being infected. We also have a possibility of adding other tests, other checks, and one check we have used to some extent is the check for some bad file types, which often contain, where the attachments often contain viruses. But we also have a discussion with the users on which type of files to live on, which type of files to actually stop. Now to the spam detection. In the earlier systems, we were normally using the Spam Assassin software, and as you probably know, this software works in a way where it performs several checks, several tests, and each test may give a spam point. And these spam points are accumulated, and when you're passing a specified limit in a number of spam points, the message is flagged. And in this case, we are flagging the messages in two ways. We're using the same flagging as with virus in the subject line, and they were also inserting a specific spam flag header within the SMTP headers. We are not using, well, our policy has been to not trash any messages in these testing phases, but instead to deliver every message. So this is a policy of just flagging the messages and then delivering them. So in order to make real use of this technique, the user has to set up some filter rules within his own mail program. well, there was one point on blacklists. We are using blacklists to some extent, but in this case, blacklists only give spam points to the spam assessing program. So we are not really blocking a domain or. Okay, so we wanted to set up this new structure on the beginning of July last year, and during springtime we heard something on a new technique called gray listing, and initially we didn't intend to use that technique here at this time, but we heard of some incredibly or impressively good results from at least one university in Norway. So we started looking into this, and when we started this new control structure, we had the gray listing added there. And I think that it was the gray listing technique that actually made quite a difference here. We saw an immediate impact. So after the change to the new control structure, we could say that spam is no longer a problem. Of the spam messages we received earlier, more than 90% were just gone. We didn't see them. We didn't have to filter them. And the gray listing technique, as we shall soon see, works in a way that we are actually not receiving the messages. We're just having a quick look at them, and we are not getting the message into our servers. So this means that the load on the normal procedures for checking spam and checking viruses, they have less messages to check after the gray listing was added. And still, we don't have to make any decision centrally to trash a message or to deliver a message. All messages arriving are delivered. That's a nice quality to tell the users. All messages arriving are delivered. We don't catch any message on the way. The effect can be shown like this. So this graph illustrates what happened when we started the gray listing control. We had one user that for some peculiar reasons had been following the number of spam messages arriving to his private mailbox. It was a person within the computing center. So every day he checked how many messages did he have that were actually flagged with spam, and how many messages did he have on top of that he considered spam, but who had passed through the flagging mechanism. So he had, as you can see in this figure, somewhere around perhaps 40, 50 messages a day, which he considered spam or was flagged spam actually. But after the gray listing technique, the new control structure was started, this dropped to a few messages a day. And all those messages after that were actually flagged, if they really were spam messages. So it's quite a dramatic change. This is just one single user I used for illustration purposes here, but I think that most users saw the same effect. I borrowed another graph from Umeå University, another university in Sweden, up north, a couple of 1,000 kilometers. And they started to use the gray listing technique somewhere around December, January. And they had been using earlier some other techniques. So the different colors here in this graph is the various filter techniques used earlier by them. So they saw, well, a similar behavior. The number of spam messages dropped quite dramatically. And If you want to have happy users, perhaps grey listing is the thing to do. I think this is perhaps the single one occasion when we have received so many positive user responses or reactions. You can see some of them here. We didn't tell anybody that we had done these changes, and we didn't tell anybody on the grey listing technique from the beginning. We just started to use the system, and we could start to use it for. We started with one or two of our subdomains, and then we added more and more domains. But rather soon we added all of our subdomains. Well, the users, this is fantastic, spam's gone. I can use mail again. I got 200 spam messages earlier. Now I see 1, 2. We also got some responses like the last one, people that there must be something wrong. I don't get any mail anymore. Well, maybe it's correct. Probably it's correct. So a little more on the grey listing technique. There's a web address there, and behind that are the definitions of the technique, and there are links to various softwares to download, and also some discussions on the technique. So Mr. Harris produced a document called The Next Step in the Spam Control War, and I think it was published in the fall of the year 2003. The technique is actually using Internet SMTP standard. There's nothing peculiar to that. The trick is just one single SMTP status command used, and it is status 451. Temporary fail, please try again later. And that's an old one, so it's not a new message. The message has earlier probably been used mostly when you had a receiving mail server being a little bit overloaded, and that mail server tried to refrain from taking in too many new messages. So it's the same message used here in grey listing, but in a little bit a new way perhaps. And this means that this status code 451, it can or should at least be able to be handled by all real SMTP servers. So if you're running on real SMTP servers following the SMTP standards, it should actually know what to do. If it receives this status, it should put the message in queue and then try to resend the message sometime later, 1 minute later, 5, 10 minutes later perhaps, or 1 hour. The trick, well, the other programs used to spread spam probably cannot treat this status message, and it's the difference here. If you have a simple or perhaps more advanced spam spreading program, it probably doesn't listen even to this message, and even less tries to handle it. But if you have a spreading program having millions of addresses to try, then perhaps it's no big deal if you miss 1, 2, 3 addresses. Just take the next one. The technique works like this. For each incoming message to the mail gateway, following 3 things are the following data is checked. In the gray listing technique, we call this a triplet. You're checking the IP address for the sending SMTP server. You're checking the sender address. You're checking the receiver address. And if this triplet hasn't been seen earlier, then you're given this SMTP status back, temporary failure. Sorry, we can't take your mail right now. Please come back a little bit later. But if this triplet formed by these three data has been seen at least 5 minutes ago, then we are accepting the message. The information we collect here has to be stored in a database, so that's maybe a minus here. You have to keep a database, and you have to keep some information in that database. It can become quite big, perhaps, if you have lots of mail. And I think we will hear in the next talk a little on how we can handle these quite big databases and can make some changes to this technique. There are some configuration parameters in gray listing, and have in most cases used the default values, but we made some changes here. Where you see an unknown address combination, a triplet here, there's always an initial delay. You always have to wait, in our case, for 5 minutes. If you try to send a message, you have to wait 5 minutes before you try the next time. You try. With you, I mean the sending SMTP server. You as a sending person never should see anything of this. So the default value was 1 hour. We thought that being a bit too high, perhaps, so we changed the value to 5 minutes, and I think you can change it to anything. You could say 1 minute, 2 minutes. The most essential is that you actually stop saying that I can't take a message right now, come back later. There's also a lifetime for new triplets, and we had the default value was from the beginning 5 hours. We thought that perhaps to be a little bit too small, so we raised the value to 30 hours. This means in practice that you actually have a window lasting from 5 minutes up to 30 hours. And if you send a message, you have to come back the second time, third time maybe, within this window, from 5 minutes up to 30 hours. There are also some other parameters for keeping old data in old records in the database. And the default value says that you could clean up the database after 36 days. The intention by having that value is that you should be able to use monthly mailing lists and things like that. If you receive a message once a month, that should be enough to keep the address active. Well, gray listing is good, but maybe not always. So you might want to do some manual whitelisting here, and there exists a possibility of doing that, of course. So you can insert the sending SMTP server. You can insert sender addresses and also receiver addresses in a whitelist, making them going through the whitelisting technique without having this delay for 5 minutes or having all these checks being made. We haven't been doing a lot of whitelisting, actually. We have whitelisted all our own IP series within the university, since these mail gateways are also used when sending outgoing messages. So, but we also had some mobile phone operators in Sweden who had a little bit peculiar ways of sending out mail messages. So we had to to include them in a whitelisting, but rather few others. We have recognized some sending SMTP servers not following the internet standards, and we have got some suggestions to whitelist them, but we will normally say, why not fix your sending server instead? It isn't following internet standards. Okay, any possible problems here? As we saw, the first message delivered, the first message from a specific address to a specific address is always delayed. So you always get a delay on your first message of at least 5 minutes. That could be a problem some ways, sometimes. The second problem might be what I said, that there are some servers out there not really following the internet standards, so they don't act correctly on this SMTP status. There might also be a problem with some sites having enormous spool queues with messages, and for them, resending a message is something that comes in the very distant future, perhaps. So gray listing is working for us today. It's probably not the final solution. We should expect the spammers to learn that we're using gray listing. We and others are using it, and we should expect the spammers to adapt to this. So don't tell them. The gray listing software, we are using it together with the SendMail, but it exists. Well, software pieces you can download for several other mail systems as well. In our case, we are using these pieces of software. We're using SendMail, we're using gray listing, which is invoked from the SendMail via the Milter function there. We're also using Mail Scanner, we're using Spam Assassin, and we're using some blacklists. Okay, and if you want more information, this is the address to start looking at. So I think that concludes my presentation. Thanks for your attention.
Thank you very much indeed. Any questions? Okay, the back, yeah. First row at the back, yeah. Do we have the microphone? Oh, you've got them. Yeah, okay, it seems like it's first to grab the microphone goes first. So.
Okay, I start. How about services using multiple outbound servers? Did you run into troubles with them?
So if they're using multiple servers to send messages, yes. There's no problem if they are have IP addresses in the same neighborhood. You actually can accept messages from another mail server being in the sub area of the.
So you define a neighborhood in a way, yeah.
And if you have this SMTP server spread around the world, and then it might be a problem.
Then you're lost, yeah. And another thing, there are some services which use database-produced messages. So the same message, when it will be sent, will use a different sender address. And I think that's a problem.
Yes, that can be a problem. Yes, we have seen that in some cases. I said the mobile phone company. And so in those cases, we probably have to whitelist.
Oh, that was the problem you referred to?
Yes.
Okay, thanks.
Who's next? We are running gray listing for some 90 domains provided by Uninet. And I just looked up the statistics, and we throw away 78.92% of their email, and they are very happy. My question, however, is we are worried that gray listing will stop working because the spammers will work around it. And a bit to my surprise, this hasn't yet happened. We put grey listing into effect about a year ago. How long do you think it will take before the spammers go around it?
I have had the same suspicion, and like you were saying, I had expected the spammers to take actions to work around the grey listing technique, but I don't think we have seen it yet. It might be that a little more messages today are actually traveling their way through a real SMTP server than before, but it's no big difference. So I don't know. I should have expected spammers to take actions right now, but I haven't seen it yet. We will see it probably.
I'm sure we will. Okay, yeah. Could we give the microphone to the gentleman at the back there? He's been waiting. Okay.
You said you are using both Sophos and Klamath antivirus software on your server. Do you use them both on each server?
I didn't follow you quite.
You said about Sophos and Klamath antivirus.
Yes? Okay, yes.
Do you use them? Do you use each program on each server?
Yes.
And
each message is passing both of them.
And how do you? How can you? What can you tell me about these programs? Which is more efficient?
I don't think I have any statistics. I would like to have it, but I don't have the statistics. We're normally running with Sophos first, since that's a commercial product where we should expect to have the updates coming in quite soon. But sometimes Clam Antivirus actually takes the virus first.
Okay, thank you.
Hi, I'm Dimitris Zaharopoulos from Aristotle University of Thessaloniki. I actually have two questions. The first is, have you identified which mail servers don't know how to handle the 451 status? Is it a server configuration problem or it's not supported by the server?
There seem to be some versions of some servers. Novell has one version, I think. There's some information behind this address where you could look those up. I think they have 3 or 4 versions and servers which are not very popular, as I see it.
Okay. And my second question is, how do you deal with the received emails before you update your antivirus software that contains viruses? I think this is a problem that many universities have, and I just wanted to ask if there's a best practice for that.
The virus detection works in a way that we are flagging the messages and we are keeping the attachments.
Okay, I'm talking about the messages that you haven't already updated your antivirus with the new signatures, and some virus emails go through.
Yes.
Do you deal with that, or you just leave it?
Hopefully we deal with it, but you can't be sure. The central spam and virus control, especially the virus control, you still should have an antivirus program on your local computer, since you could have viruses arriving in separate other ways. It mustn't be a main message.
Okay, thank you.
So always have an antivirus program on your computer.
Okay, I think last question there.
What we have seen is, and that I guess you didn't see yet, is spammers which use the relay service of an ISP to send their mail. And obviously that's not helping when you use grey listing, because that's a normal mailer and it's only there for them to relay the mail. How can you do something for that with grey listing? Or is it just the end of grey listing then?
That could be the problem we would expect to see, that more messages are going away through an ISP with a real SMTP server or any other organization having SMTP servers usable in that way. But normally, I think that you could contact an ISP if that happens and have him to block. You still can do that. But it could be a problem that more spammers are using real servers, or trying to find those real servers that are still open in some way.
Okay, shall we thank Torgny very much for his talk? Our next speaker is José Marcio Martin de Cruz, which I know I haven't pronounced that exactly correct, but it's an English-Spanish pronunciation, I suppose. And he's from the École des Mines de Paris, and he's going to give another talk on spam filtering, only this time he's going to look at what they've done there, which is a mixture of behavior and content analysis of email messages.
Yes. Okay. Hello. Well, I will talk about a small filter we built at the École des Mines. The original goal was to have a filter able to handle medium-sized states and messages without too big machines, the small machines. Excuse my English, I don't speak English very well, but I speak better than Chinese. Well, about the medium or huge mail servers, I'm interested. I talk about servers handling messages for some thousand users, or many 100,000 messages each day, and many gigabytes each day. So typically, it's a university campus gateway. What happened with this kind of servers? In university, you have many different populations. You have computer science. Computer science usually receive messages, legitimate messages, talk about computers, low-price computers, or something like. Physicians may receive messages about Viagra or similar. Sociologists may receive messages about controversial subjects. Purchasers usually receive messages about many advertisements. So it's very hard to define what a typical mailbox looks like. Usually many filters like spam assassin or Bayesian filter are based on the idea you can have perfectly know what the composition of a typical user mailbox. Another problem is that the users usually, an university campus mail administrator usually don't know each user receiving messages passing by his servers. So when there is feedback, it's useless. So it's very hard to tune the filters. Another problem is that usually filters are done on gateways. An university campus usually have sometimes have a gateway and incoming gateway and other mail servers for each department, as explained Torgen. So at a gateway, you usually don't have information about users other than if some user exists or not. Problem for security issues. Usually very well known machines. Reliability. If a gateway you have a problem, if it's unavailable, usually 1,000 people will call by telephone to ask what happens, why I can't send mail, I can't receive anything. And usually you have also other problems, low-level hardware or operating system problems, which you you don't have if you're running a mail server for 100 or 200 users. Let's recall how works SMTP dialog. The first part is the envelope. It's a postman arrives and tell, hello, I'm the postman, I'm calling, my name is Callaway, and I have a message from Joe. And they say, okay, Joe. And I have a message to Martins, okay, and to Tompion, oh, I don't know him. This is the envelope. It's the same as an envelope, paper envelope. You have very few data, and what happens here, it's very fast. So if you can filter in this part of the dialogue, it's better. You don't spend too much CPU cycles. After that, the message board, you can have many megabytes of information there. Though if you do filtering there, it's much heavier processing. So let's recall what we usually found when we do mail filter. Behavior filters, this is some not really true, but let's consider something like. Behavior filters looks at some parameter and try to verify how it evolves with the time. For example, the connection rate, I have some examples before. RBLs, this means blacklists. This particular IP address was seen sometime before sending spam. So it was put in blacklist. Spam traps, we can put hiding address on some web pages. And after that, you see this machine was sending messages to this address. I can block them. Connection rate, try to identify if you have bursts. Each person, when the normal people send messages, the time between two messages is usually in random variable with exponential distribution. So a robot, in general, it sends bursts. So the mail server can say, try to identify bursts. And greatest thing is something Torgny explained. You can do some other things like conformity on hello. When I said before, when I present myself, I said, I'm the postman, my name is Callaway. And usually another thing which happens commonly is someone who connects to your server, he says, it's me. He told the name of the server which will receive in the message. So this is some trick to avoid being blocked. Content filtering is based mainly on the content itself of the message or the headers or this kind of thing. And you can do many kind of techniques, from pattern matching to check for some regular expressions, or to identify, for example, try to identify the mean size of words found in the message. So usually when you do content filtering, each new connection is a new event. You don't learn nothing about what if you receive, if you handling the third message from the same gateway. For you do it the same way it was the first time. Well, some kind of content filter is the pattern matching. The first, the simpler one. This means you have a list of expressions you don't want, for example, Viagra or some medical products, and each expression will be checked against the message. So the problem is that the message will be read the same number of times that then you have the different expressions. So this is very resource consuming. And usually you can define not more than some 100 expressions. It's some limit. It's very hard to maintain, as for example, someone may write Viagra and replace the I by 1. So a reader can read it, will understand, but a computer may not understand this. So you need to or define more complex expressions or define 2 expressions for the same word. Another kind of content filtering, very interesting, is the URL filter. As every message, spam, usually you have 2 things. Always, there are 2 things you have always. A telephone number or a domain name, a URL, address of a website where you can go to see what the spammer is advertising. So the idea is you extract all the URLs you spam, a very large database. For example, I'm talking about surbl.org. This is a database very interesting, as it has about 120,000 domain names, different domain names. And you can do this, and it's very, very fast. Another interesting thing on this database is, for this particular database, is that the strategy is a simple phrase, which means if it appears in ham, don't list it. This means if you see that domain name, it is nearly sure it's a spam. So it's independent. There is no dependence between this database and some other things like Bayesian filters, which depend on the typical user database. And Bayesian filters, I think everybody knows this. Bayesian filters, it breaks down the messaging in little bytes, usually words, and we'll check. For example, I found a word Viagra, and it appears 9 times in the spam and one time in ham. So the conditional probability of being a spam is 90%. Heuristic filters have usually some 100 different tests, checks, and will assign a final score to the message depending on the score of each text. The problem with both filters is that they depend on some previous learning, and they learn how your mailbox looks like. Don't you have some level of dependence from the typical mailbox? Let's quickly see how is the life at user servers. Here is the data from 6-hour mail filtering from domain prolocation.net. What's interesting to note here is the higher number of messages which were detected by domain names, URL blacklists. Another interesting thing is the higher number of messages detected by heuristic filter, which are non-reliable criteria. I think I'm late. So we can see the blacklist, the URL blacklist is and very external criteria, URL and IP blacklist are very more effective than others. This means we have some dependence. This filter has some dependence from external source of data. A little word about the blacklist, the IP blacklist. This is a little sample from our domain. From what you can see here, the second line means the number of messages blocked by the connections blocked from end user ISP clients. So using this blacklist, I don't think, I'm not telling this is a bad idea, But you should understand that if you use this blacklist to block something, you're really blocking connection from ISP end users. You do that at our domain. So the idea to scale filter is the first thing is that I'd like to be able to use their small machines to filter a big traffic. So the resource consumption shall grow slower than the traffic level. Another interest point is to remove external dependencies as DNS checks and network checks. And if you really need to do that, you should have a local database of this, a copy of DNS or network. Try to use only reliable criteria. This means avoid to use criteria which depend on the classification of the typical user mailbox. If you can do behavior check, it's faster than content. Don't lose time. This means try to use very fast checks, not long checks. And try to learn why the filter works. This means try to store the results of previous filtering in order to be able to have some idea of when a new connection comes from some IP address. You may have a previous information of what can be coming from this address. Behavior, what we do, behavior check and check mail. We have a set of very fast checks, the connection rate, bounce rate, spam traps, harvesting, people trying to guess a final address. And for a kind of thing we do is if someone makes more than some number of mistakes, he gets blocked during 4 hours time. Though this is a kind of real-time blacklist. We have 3 levels of history. A short history of about 20 minutes where we store some numbers from each client who connects to our mail servers. For example, the number of connections, the number of messages, the time is spent by the filter to handle connections from these clients. The medium histories mean people with bad behavior. For example, people trying to guess addresses or sending messages to honeypots. And a long history, it's a database in disk with confirmed bad behavior. Donc, behavior filter doesn't block too much spam, but protects the server against you. We will see this again. Another thing we use is the URL blacklist from surbl.org. And pattern matching, we use it as an auxiliary criteria. And the heuristic, we have very few criteria, 31, but we are removing all them which are not reliable enough. Content filter, seen by the user, what is important is to say the user you have a filter with 99% of detection, but something will help you to put the good message in the inbox and bad message on the spam box. So he usually have a little filter will help them to configure this way. Message coming from no users, he put it in normal inbox, and the message with high score in spam box. We have some cooperation in content and behavior. This means, for example, behavior threshold. For example, we do connection rate control, but we also do content filtering. And when we detect gateway sending too many spam messages with high score, we divide by 2 the allowed connection rate for this particular client. And you do the same in other sense. For example, a gateway who's standing, doing some guessing recipient address, but not too much. It's dubious. You can use this to hide as an initial value for the content score. Another important thing is to avoid closed loops. Otherwise, the content, we have some influence on the behavior, and the behavior is high. It will have a feedback against the behavior. This is something we have under validation at our domain about gray listing. Gray listing has a problem. It's really easy to scalable. The number of hackers may grow very, very fast, and I will present you some results. A gateway from Jussieu usually have 500 or 600, usually 500,000 entries, but sometimes this number may grow to 1 million entries. This may be a problem. Another problem is it's very easy to poison the database. To create databases, for example, if you try to send 1,000 messages to 1,000 different users, they may create 1 million entries on the gray database. The idea is, as we measure entries older than 12 hours, have the probability that they will be validated is less than 1%. So it's very redundant. The idea is to eliminate redundancy and to give different lifetimes in function of some quality level of the entry. And what we are doing, original gray listing has only 2 databases, the pending database as explained Tony. And what we are doing is to, the first pending database, we use at our domain 3 days lifetime. And the second valid database, we are using 1 week. And the idea is, I will examine both databases to try to eliminate the unwanted pending entries. And for example, at valid database, if I detect many entries from the same IP address and the same domain name, I can group them to form not a triplet, but a pair, a couple, IP, and from domain. And in fact, we don't use really the IP address, but the network from the IP address, which allow to solve the problem raised by someone when the same message may come from different servers. Here we have a little result which showed that with very simple verification, we can remove 85% of the entries from the database. And I put a graphic from a distribution, a histogram of daily distribution of the pending waiting entries. When you show that the first day you have a try of database poisoning. Usually they have 100,000 new entries a day, and the first day they have near 400,000. And if I look at the distribution by IP address, you have some dozen entries IP address with more than 20 or 30,000 entries non-validated. Well, how we protect our server? The first thing is to system auto restart. If the filter dies, it's relaunch again. Connection control, we do control the number of simultaneous open connections at the same time. We made the server load the measurement, and depending on this, we can adapt our filtering strategy. So we have an example of the connection rate. At the left, you have two big sources of, I don't remember the number, but it seems 20,000 connections in 10 minutes. And at the right, they were rejected and without no influence on the normal messages. This we have the 10,000 connections for a near entire C class, and you can consider no real message were lost. Virus filtering, what we do is to block a message with some kind of executable files. It's very interesting to do, also to monitor, to look what your filter is doing. Here's an example. When I can query the filter in real time, it takes 1 second to have the answer, to ask what has been done last 6 hours. And he say me, he handled 9,300 connections from some number of gateways. And what is interesting to note here is the mean time, handling time of each connection, 28 milliseconds. Example of filter, NSMP.fr, our domain. Jussieu, it's a big university, a big campus in France, which handle messages for 50,000 users, and they handle 100 connections a day. And on the server load, it takes about 30 megabytes in memory and about 3% of CPU. Another big domain is PO Box in Slovakia. You can see it takes 150 megabytes and very light CPU usage. What's important to say, it's a very fast filter, and what really blocks interesting things in the filter is the behavior which doesn't block too much spam, but allows protects the server. Gray listing, which allows to block too much spam, and content filter based on URL database, which blocks too much spam. Donc, conclusions. During the filter working time, lifetime, there is many data which we can take into account to do filter more than we can imagine. This is why I wrote the next phrase, learn while you work. This means do real-time analysis on those preview filtering results. And the 3 filtering methods which are the most effective, no matter if it's our filter or any other, is the connection rate control. We began to do this, and now 3 years ago, and now there are many other filters used. Gray list and URL filtering. Donc, people I'd like to thank Tibor. I don't know him personally, but I think he's here. And Raymond is there. The other people helped me to get data and develop it.
Okay, thank you very much. Do we have any questions, please? Yeah, up at the back there.
I'm from University of Porto in Portugal, and I have a question. This presentation and the other one all refers only to incoming spam.
Yeah.
Do you treat the problem of outgoing spam with SPF or other things like that?
No. Outgoing spam, usually if I understood your question, this is a spam sent by other domains which you have no control. I don't know if about this you are talking.
No, look something.
It's messages going out from my domain?
Yes. Or outgoing from some spam machine with your domain to my domain.
Our filter is mainly used in universities, so I can consider that there is some policy inside university which don't allow people from there to send spam.
Okay.
I can't imagine someone from our university sending, I don't know, some pornographic messages to outside.
Okay, thank you.
Thank you. I would like to ask, there is a way to create different URLs that lead to the same web server. How does the blacklist of the URLs deal with this wild character situation?
We check some domain part. For example, sex4free.com. If someone adds something at the beginning, he may add any number of under domains, and I always check finally at the end.
But then it is dangerous to, perhaps if you are very aggressive with this, you might be able to cut legitimate traffic as well. If a URL, if the first part of the URL is okay, say, I don't know, Yahoo or something, and then the next part is randomly generated, if you are very aggressive, you are going to also cut legitimate traffic.
But I'm not sure I understand, but either way, this is much lighter than doing pattern matching, for example.
Yes,
so if, no matter if you add something, I can't imagine, for example, someone create 10,000 characters domain name, handle domain names.
So you cut the whole domain name or the URL, after the domain name part, after the slashes?
I will check, for example, if you put xxwww.freepornforall.com, I use this last part.
Okay.
Do we have any more questions? Okay. Well, thank you then, Josie.
Thank you.
That's the end of this session. We now have a tea break, I believe, and we start again at 4 p.m.